So, hi everyone, this is Dr. Srikanth Yadav, Associate Professor, Department of IT. So, we are going to discuss about the concepts of machine learning as a part of the curriculum. The machine learning will cover the basic concepts of data mining, data warehousing and various internal operations of data mining. This is going to be the syllabus of the first unit. Let's move to the actual syllabus and we will discuss one by one in detail. So, these are the topics which are going to be covered in module 1 unit number 1. Introduction to data mining and various data preparation and pre-processing operations. Coming to the introduction of the syllabus, we will see the role and need of data mining in real-time applications and different kinds of data and patterns that can be mined. That means, what are the various types of data which are available and what are the different kinds of patterns that can be used in data mining are going to be discussed in detail. And later, we will see the introduction to machine learning, various types of machine learning concepts, types of machine learning approaches with some real-time applications we are going to discuss in detail. And at the last, we are going to discuss applications of machine learning. Let's move to the actual syllabus and the course outcomes of the syllabus. Upon completion of this course, the students are able to perform the following activities as a learning outcomes. The first one is a course outcome. After applying the machine learning fundamentals, model training techniques and various validation strategies, performance evaluation metrics across various algorithms like classification, regression, support vector machines and so on. And the course outcome 1 is mapped to the following programming outcomes: PO 1, 2, 3, 4, 5, 9, 12, and it is directly mapped with the program specific outcomes 1 and 3. Coming to the second course outcome, upon learning, the student is able to understand and apply various supervised and unsupervised learning algorithms including decision tree techniques, regression techniques, various ensemble techniques like k-means algorithm, principal component analysis, and they can understood and they can apply the various algorithms and they can measure the strength and weakness of algorithms by applying on various data sets. And coming to the third course outcome, the student they can evaluate by applying various ML models on different real-time data sets and they can measure and they can compare the performance of various algorithms by applying performance metric techniques like accuracy, precision, recall and various metrics related to the concern classification algorithm. Coming to the fourth course outcome, students are able to apply and create various intelligent systems which are fully equipped with ML approaches as a part of their project or mini project and various programming related activities on machine learning. Coming to the actual introduction of data mining, why we need a data mining? In real-time applications, why we need a data mining? Let's discuss in detail. If you observe the explosive growth of the data from digital era, that is from 1960 to till date, the growth of the data has been moved from terabytes to petabytes. That means day by day we are getting exponential growth of the data in real-time applications. So, the major size of the data is terabytes to petabytes. So, in this scenario, how we can handle this enormous amount of data and this voluminous of data and variety of data in real-time applications? The first and foremost activity is data collection and data availability. How and how many ways we can collect the data and what are the automated tools which are required to collect the data and what are the various database systems and what are the other sources of data that data is getting generated in larger amount of size. And coming to the second one, what are the major sources of this much abundant data? We will see some of the real-time applications like business applications, web, e-commerce, transaction related like banking systems, share market applications. These are the various large amount of data sources. Coming to the science and technology, like remote sensing, bioinformatics, scientific simulation are the other scientific applications and technological applications where large amount of data is going to be generated in day-to-day activities. Coming to the third one, society and everyone, like the common public related activities like social media network, blogs, news applications, articles, and all other applications where data is going to be generated in large amount of data. And coming to this actual role of data mining in real application, we are drawing in data but starving for knowledge. We may have large amount of data, but our ultimate goal is we need to extract some effective information from the large amount of data. That is, extracting the knowledge is a major concern and major challenge in real-time applications. Coming to the evaluation of technology, we will have a small and detailed discussion on the evaluation of database applications. In 1960s, the major concern was collection of the data, creation of database, and creation of various network database systems. That is a major concern and major activity in 1960s. Coming to 1970s, the evaluation and advancement of 1960s were done by implementing and using relational data models. That means RDBMS concepts are going to be applied on the data in order to understand the relation between the data and the objects, and implementation of various DBMS approaches. In 1980s, advancement of RDBMS came into the picture by incorporating various integrated approaches like extended relational model, object oriented model, and deductive models. So these are the advancements for existing relational database systems which was happened from 1980s onwards. And at the same time, various application databases are came into the picture from 1980 onwards, like application oriented data has been collected. Example, the spatial related application, the spatial data has been collected. Scientific related applications data has been segregated and separated and kept in a separate model. Like engineering related data has been collected and separated based on their domain and application. Coming to 1990s, the actual data mining term was coined. Now, till 1990s we are having large amount of data, but we are using that large amount of data only for transactional activities. Now our concern is to analyze the data in order to understand the hidden patterns of the data, to extract knowledge from the data. We need some more advancement techniques than RDBMS. So the data mining concepts came into the picture. At the same time, to store a large amount of data repository based on the application oriented data, so the data warehousing term came into the picture. So it is going to be used for historical purpose. Large amount of data is going to be kept in a repository and it is going to be used in larger scale and kept maintained for number of years. At the same time, various multimedia databases are also came into the picture, like web databases, like YouTube applications, social media applications, multimedia applications, graphical applications, scientific applications. And from 2000 onwards, we are having advancements in data like stream data mining, how the large amount of network and real-time data streaming is going to be done, and how the streaming is maintained, and how the data mining techniques are going to be applied on the streaming data mining. At the same time, incorporating of web applications and web technologies in the data mining concepts in order to handle web related data also in real-time applications. Let's see what is a data mining. In layman words, we can say extracting knowledge from large amount of data. We can call it as extracting knowledge from large amount of data. Now, how can we extract the data from large amount? Let's have this simple definition. Extraction of interesting patterns or knowledge from large amount of data. We are not only extracting the patterns, we are looking for interesting and knowledgeable patterns. So in order to achieve the task, what we require a non-trivial, implicit, previously unknown, potentially useful data is going to be used in order to extract the hidden patterns of the data that can be used as a knowledge output from the large amount of data. Now coming to the alternative terminologies and names which can be used as a synonyms for the data mining. One commonly used one is the knowledge discovery. Knowledge discovery from large amount of data. We can also call it as KDD. Knowledge discovery from large amount of data. And knowledge extraction is also another synonym that can be used in place of data mining, like pattern analysis, data archaeology, and data dredging, information harvesting, and business intelligence. These are the various synonyms or keywords which are used in place of data mining. And what will be the main objective? Is everything can be mined or everything a data mining? No. A simple search query operation, we can't call it as a data mining. At the same time, we are looking for an expert level operations in extracting the knowledge. Let's have the procedure and a detailed analysis and various steps which are involved in KDD process. The full form of KDD is knowledge discovery from large databases or knowledge discovery from databases. If you look at the view of the data, there are 7 internal phases which are going to be applied in order to extract the knowledge. The first and foremost is we require a collection of data. That means we are collecting data from various operational sources or operational data sources. We are collecting data from various operational sources into a single module. We are calling it as a data. And whatever data we collected, we are applying an operation called data selection. We are not going to apply data mining techniques on the entire data. We are going to apply mining technique on the task relevant data. So based on that, the portion of data is going to be selected. That selected data we are calling it as targeted data. Whatever targeted data has been selected, that has to be pre-processed. Now what is meant by pre-processing in this approach? Whatever data we collected for mining activity, it should be free from impurities, such as a data may have some missing values, like employee age is missing, or a data may have some null values, like in the place of salary we found a value called -1, or in the place of age of an employee we found some abnormal number like 451. 451 we can call it as a number, but we cannot consider it as age of an employee. That means there is some misinformation was there in the age. That means one of the digit may be entered wrongly. Or look at the salary. Salary cannot be a -1 for an employee. So it can be treated as a noisy. And some information like employee designation is missing or employee gender is missing. So in this case, how this can be replaced? That means whatever data we are using, it should be free from impurities. Here impurity in the sense it may not have missing values, or it should be free from noisy, and it should be a complete data. It should not contain any incomplete information. So those techniques we are going to apply in the form of data pre-processing here. Once data was pre-processed, that pre-processed data can be used in order to achieve our knowledge. That is, we are going to apply various data transformation techniques. So in order to convert data into our convenient form, we may use data transformation technique. Like I want to bring all the salaries of an employee by applying a min-max normalization into the range of 0 to 1. That means here we are bringing all the salary, that numerical values of the salary attribute into the range 0, 1. If needed, we can use this transformation technique here. So this is a major operation, converting data into the convenient form of the application or the target. Once the data transformed was done successfully, we are going to apply various data mining techniques on the transformed data. Now, what are the various data mining techniques that we are going to see in due course? Just broadly, let us assume we are going to predict the student marks in the next semester. We are having internal marks, we are having all target marks, and we are going to predict his expected summative marks. So, in this case, we are going to analyze his target marks, that is formative assessment marks, and we are going to analyze in our prediction. That is one of the data mining activity. So, data mining is having a number of techniques that we will see in later. Once the data mining was applied, the output of data mining activity, we are calling it as a pattern. So, hidden pattern was identified, and we are going to apply some data interpretation and evaluation techniques on the data which has been extracted after applying the data mining. Finally, we are going to achieve the concept called knowledge. So, once the data has been processed under these phases, finally we are getting a concept called knowledge. That is called extracting knowledge from large amount of data. So, initially we collected data from various data sources. It can be operational data, it can be banking sector data, or in an organization data may be generated in various forms. It can be from R&D section, or it can be from manufacturing, or it can be marketing section. So, all this large amount of data we collected in a single source, in a single environment we kept, and we selected only the specific amount of data based on the target, that is called selection of the data, and we applied data pre-processing techniques on the targeted data, and the pre-processed data has been undergone for the transformation, and the transformed data, on the transformed data we applied various data mining techniques, and from the as an output of data mining we received some patterns, and those patterns, after applying the interpretation, evaluation and data visualization techniques, finally we are getting knowledge. So, this is called KDD process, a stepwise KDD process which involves various operational activities like data selection, transformation, data mining, interpretation, evaluation and pre-processing. In some cases, we may go with the data post-processing operations also, that we will see in due course. At the same time, if you observe closely, data has been converted into various forms. Initially, data is in very large scale and some portion of the data has been collected. If you observe closely, data may be in larger scale or smaller case will have the same property. So, that is why we can call it as it is a data mart. A portion of data we are collecting or we are applying on a specific location. At the same time, we are applying data pre-processing operations on the data. Now, what are the pre-processing techniques we are applying? Handling missing values, removing noisy, removing other impurities from the data like inconsistencies and imbalance information. Let us move to the another concept, the flow of the data in data mining. If you observe closely, as we discussed in earlier, the input data will undergo for the data pre-processing operation. The data pre-processing operation that we are going to apply is data integration, normalization, feature selection and dimensionality reduction. And once data was pre-processed, we are moving to the second section called data mining. In data mining, we are going to apply various data mining techniques such as pattern of discovery, association analysis and correlation analysis, classification and prediction, clustering analysis and outlier analysis. Once data mining has been applied on the data, we are applying post-processing operations. That means whatever output we receive from the data mining is going to apply various post-processing operations like pattern evaluation, selection, pattern interpretation and pattern visualization. So, these are the major three basic operational activity where we are going to apply on the input data. Let us move to another major concept Till now in the previous slide we discussed about a word called data. Now we will see what are the different kinds of data which are available in real time applications. If you observe closely, there are 4 types of data that we can use. First one is a relational database, second one is a data warehouse, third one is a transactional database, and the fourth one is, if you observe closely, all these comes under advanced databases. We will see in detail one by one. The first one is transactional database. Let's discuss about transactional database. Let us have a customer went to a shopping mall and he purchased 2 or 3 items and he went for billing. If you observe closely, whatever items he or she purchased will have a transaction ID. And against to this ID, let us take the transaction ID is 12136 and it will have the list of items he or she purchased. Like they purchased some bread, milk. If you observe closely, the items whatever they purchased in the transaction will have a one unique number. That's called transaction ID. So whatever existing transactions, if we keep and arrange and use in a format like transaction ID by assigning one unique number against list of items, such database is called transactional database. This attribute or this column is most important in order to predict or in order to analyze the transactions by retrieving or by using transaction number. Coming to the second type of data, that is RDBMS, Relational Database Management System. If you observe closely the word called relation, a set of tables or a couple of tables may have a relation, because the basic definition of data mining is collection of relevant data. Let us take the student and faculty table. The student and faculty or student and class will have a relation for a particular amount of time. Like this, department and classroom, student and department. Like this, whatever data we are collecting will have a relational format, that is called relational database format. Coming to this relational database format, there are some key aspects we need to focus. First one is relational database format will have a 2-dimensional format, that is data is going to be represented in the form of rows and columns. That means the total data was organized and represented in the form of a tabular form. So here the representation we are using is a tabular form. And one more thing is, we are going to apply the entity relationship techniques, that is called ER approaches, in order to retrieve the relationship between the tables and the entities. We are going to apply entity relationship techniques. And coming to RDBMS, mostly the data in RDBMS is used for transactional activities, that is day-to-day activities we are going to use. That is one of the major concern in this RDBMS. And coming to the third one is data warehouse. So in the earlier we discussed about RDBMS. In data warehousing, data is going to be represented in 3-dimensional format. This is called a cubical structure. Data is going to be represented in a 3-dimensional cubical structure or cube structure. Example, it looks like, visually it looks like this. That means a cube may have more than 2 faces. That means maximum will have 6 faces. And coming to here, data warehousing mostly used for historical purpose. We are not going to use the data in data day-to-day activations. We are going to preserve the data for historical aspects. This is one of the major data operations in data warehousing. And the fourth one is advanced data sets and advanced applications. In this fourth category of data that can be mined, we'll see one by one. First one is data streams and sensor data. That means if you are having an input data, which data is coming continuously, like online YouTube channel telecasting or online cricket match broadcasting, and getting data from sensors, like we are getting sensors from which are installed in a swimming pool, which are going to be used to measure the pH value of the water, and dashboard is collecting the data. Based on the data and values of pH, the concerned person take the necessary measures. Or we may be collecting sensors data in a shopping mall for inventory management. And coming to the next one, time series data, temporal data and sequence data. Best example for time series data is stock market and a live cricket match predictions. In stock market, the price value of the share is going to be measured and it is going to be observed. Based on the value of the share, the decision can be taken. And biological sequence, DNA sequence, RNA sequence, where time is going to be play a crucial role, like measuring the weather forecasting. All these comes under time series and sequential data. Coming to structural data, data is in the form of a structure, in the form of tabular form, mostly in the tabular form. Graph applications, social network applications, multimedia linked data. This is one of the advanced related to social networking applications and multimedia related applications. Coming to the next one is object oriented database or object relational database. Embedding object oriented programming concepts in databases is called object relational databases. Like we are adopting object oriented concepts like inheritance, multi-level inheritance or single level inheritance, polymorphism concepts in database applications. And coming to the heterogeneous and legacy database. Now what is heterogeneous? Whatever databases we discussed in this slide, if we collect all together in a single location, we can call it as heterogeneous. Collection of various types of databases is called heterogeneous. Collection of heterogeneous databases, we can call it as legacy database. If you are having multiple heterogeneous databases and we combine into a single, that's called legacy database. Coming to the next one, spatial data and spatial temporal data. The spatial related, geospatial related applications where data is going to be collected. Example are transportation system like Ola, Uber, and food delivery applications like Zomato, Swiggy. They are going to use Google Map applications. So that is spatial data and spatial temporal data applications. And next one is the multimedia databases. Commonly used multimedia applications are YouTube is one of the commonly and most popular application for watching videos or uploading videos. And next one is text databases. Like research related databases will have various text databases like IEEE, Inspect databases are there. And next one is the World Wide Web. Like one of the World Wide Web application is the internet. So if we combine all these applications, we'll call it as heterogeneous. Collection of heterogeneous is called legacy databases. If you observe closely, broadly there are four types of data that can be used. One is relational database, transactional database, data warehouse, and fourth one is advanced applications. In that advanced applications, we are having time series, sequential database, temporal database, network database, graphical database, object oriented database, spatial, temporal and spatial databases, textual databases, worldwide applications, multimedia applications. Altogether we are calling them as heterogeneous, and collection of heterogeneous we can call it as legacy databases. If you look at all these names what we discussed, you can imagine enormous amount of data is getting generated day by day. That is the reason in the initial session we discussed what is the use and why we need to use a data mining. In order to perform various analytical operations on the data, This is the reason we are having enormous amount of data sources are available in real-time applications, and the size of the data is getting increasing from terabytes to petabytes day by day. Let's move to another concept. What are the different patterns that can be mined? That means we used a word called data mining or data mining techniques. Now, what are the actual classification of data mining techniques? In data mining techniques, there are two types of patterns that we can use. One is descriptive data mining, second one is a predictive data mining. Let's move what is descriptive and what is predictive. In descriptive mining, majorly there are a few techniques are there. One is a clustering technique, association analysis, frequent pattern analysis, correlations and class or concept. Let's see a real-time example for each and every technique. In clustering, look at the example. We are grouping the customers by using their purchase behavior. Example, segmenting online shopping into bargain hunters or loyal customers. Based on their purchase amount and their behavior, we are going to group the customers. That is one of the best example for clustering. Now look at the association analysis. One common application under association is market basket analysis. If a customer buys a bread, are they likely to buy a butter? That is our question. So here the transactions are represented in the form of X tends to Y, where X is an item set, Y is an item set. So these two terminologies we will see in due course. So here we are predicting whether the customer is going to buy a butter along with the bread or not, or vice versa. Coming to the next one, frequent pattern. What are the frequent patterns which are occurring in the transactions? Example, identifying the combination of items that frequently occur in transaction, like milk and cereal frequently brought together. That means most of the customers are buying these two products together. That's called frequent. That means if you are understanding the word called frequent, the opposite to this frequent is infrequent. That means very less combination of products are going to be bought. So in this case, we are not focusing on infrequent, we are focusing only on frequent item sets. Coming to the next one, the correlations, like how the attributes are correlated on each other, like time spent on site and purchase amount. How much time the user has spent on online application, like online e-commerce application, and what is the purchase amount. Are they correlated? If they are correlated, how they are correlated, whether they are positively correlated or negatively correlated, that we are going to analyze. And the fifth one is class or concept description. Look at here, describing the profile of a premium user in a streaming app. Example, like Netflix or Amazon, we are going to describe the profile of the premium member, like what is the age group, what is the viewing habits. Based on that, using the recommendation systems, they can recommend the content based on their past history, view history and search history. These are the commonly used applications under descriptive mining. That means we are explaining the content in detail, not in a single word. We need to explain, we need to give the justification for each and every question to be arranged in all these activities. That's why reason it is called descriptive data mining. Coming to the next one, the predictive data mining. Under predictive mining, the popular mining techniques are outlier analysis, evaluation analysis, regression techniques and classification. Let's have a real-time example for each and every technique here. Under this predictive pattern, the first one is outlier analysis. Detecting the fraudulent transaction in a credit card data. That means if any person's credit card or debit card or any other online activity was misused by any unknown or fraudulent activity, how we are going to predict it. That's called detecting fraudulent transaction in the credit card. If any object which is behaving abnormally than the normal behavior, we can call it as abnormal or outlier. So in some cases outlier can be treated as a positive, it cannot be treated as a negative also. Like we are having a bunch of 50 yellow balloons and we kept one red balloon. The red balloon also will have the same property like yellow balloon, but it looks different. That's why you can call it as outlier. Coming to the next one, evaluation analysis. Analyzing the customer behavior trends over the time. Analyzing the customer behavior trends over the time. Example, shifting preferences from desktop to mobile use, or buying a new mobile over the existing one. What are the features the user is looking? That's called evaluation. Coming to the next one, regression. The best example is predicting the temperature, predicting the share value, or predicting the house price, which are deals with the numbers and numbers only. Predicting house price based on the square footage, number of rooms and various attributes. And the next one is the classification. Just have a look example, you can easily understood. Email spam detection. Everyone who are using email, if you observe closely, some of the mails will be moved into primary, that is an inbox. Some mails may be moved to spam. Now how the mails are getting and moved into the spam? Some keywords or the URLs, text or any inbuilt images which are there in the email, and the email sender is first time to us. In those cases the email will be labeled as spam and it will move to spam. If it is not in that case, normally it will come into our primary. That's called spam versus not spam. Coming to the disease prediction, based on the symptoms of the patient, whether he was affected with the COVID positive or negative, we are going to assess. This is called classification. So these are the commonly used techniques which are related to predictive data mining. Thank you.